In the last few videos, we talked about comparing numbers with large exponents or irrational exponents. In this video, we will try to use the concepts that we learned to solve a very challenging problem. The source of this problem is 2018 Bulgarian National Olympiad problem number 3. Here is the question. Prove that 6 over 5 to the power of square root of 3 is larger than 5 over 4 to the power of square root of 2. Since square root of 3 and square root of 2 both are irrational numbers, to simplify the question, we apply square root of 3 on both sides, and we get 6 over 5 to the power of 3 larger than 5 over 4 to the power of square root of 6. At the next step, we need to find a rational number close enough but larger than square root of 6. To do so, we will use the iterative method by letting square root of 6 be 2 plus x, and after a few steps, we have x equals 2 over 4 plus x. We then define a number sequence xn in which xn is equal to 2 over 4 plus xn minus 1, and we set x0 as 1 over 2 here, because square root of 6 is not close to 2. The calculated x1 is 4 over 9, and 2 plus x1 is 22 over 9. If we compare this number with square root of 6, we will find out it is less than square root of 6, and this is not what we want. Therefore, we have to go one step further. x2 is 9 over 20, and 2 plus x2 is 49 over 20. And we have to do the same thing, compare this number with square root of 6. And the result is it is just larger than square root of 6. And this is what we want. So, in the next step, we will use 49 over 20 to replace square root of 6 in the proof. In detail, 6 over 5 to the third power larger than 5 over 4 to the power of square root of 6 will be true if we can prove 6 over 5 to the third power larger than 5 over 4 to the power of 49 over 20. And we will apply the 20th power on both sides, and we get 6 over 5 to the power of 60 larger than 5 over 4 to the power of 49. And the next step, we multiply both sides by 4 over 5 to the 60th power. This is to reduce the power on the right side. And this is equivalent to 24 over 25 to the 6th power larger than 4 over 5 to the 11th power. This becomes what we need to prove at the next step. "24 over 25 can be written as 1 minus 1 over 25. And now we need to estimate the value on the left side. If we take the 60 power, then we will find out the a over bn is less than 1 over 2, which is too small. That means we cannot use the binomial expansion directly. Instead, we write 60 as 5 times 12. And if we only use the binomial expansion on the inner side of the bracket, 1 minus 1 over 25 to the 5th power, then a over bn here is 5. This is large enough for us to do the binomial expansion. And let's do it now. We take the first 4 items of the binomial expansion. Why 4 items? Because we find out only the first two items are not enough. So we have 1 minus 1 over 25 to the 5th power equals to 1 minus 1 over 5 plus 10 over 25 squared minus 10 over 25 cubed, etc., which equals 4 over 5 plus 240 over 25 cubed, etc. Please pay attention. We have a 4 over 5 here, which is also the right side of the inequality. This will be very helpful. So, since 1 minus 1 over 25 to the 5th power larger than 4 over 5 times 240 over 25 cubed. Therefore, if we want to approve 1 minus 1 over 25 to the 5th power then to the 12th power larger than 4 over 5 to the 11th power, we need to prove 4 over 5 plus 240 over 25 cubed to the 12th power larger than 4 over 5 to the 11th power. We will do some manipulation on both sides. The first step is to multiply 5 over 4 to the 12th power. Then we get the following inequality. 1 plus 12 over 25 squared to the 12th power larger than 5 over 4. This is the next inequality that we need to prove. And for the left side, we need to use the binomial expansion again to estimate the value. Before we do so, we briefly calculate a over bn, which is larger than 4. That's good enough. So we take the first 3 items of its binomial expansion. Why 3? Because probably 2 items might not be enough. So the polynomial is larger than the sum of the first 3 items. So if we want to prove 1 plus 12 over 25 squared to the power of 12 larger than 5 over 4, we need to prove the sum of the first 3 items of its binomial expansion larger than 5 over 4. And after we briefly calculate the first 3 terms, we get 12 squared over 25 squared times 66 times 12 squared over 25 to the 4th power larger than 1 over 4. And we multiply both sides by 4 times 25 to the fourth power and get 4 times 12 squared times 25 squared plus 66 larger than 25 to the fourth power. This is fairly easy to prove, but still, if we use some tricks, we can make the proof easier. And let's calculation steps. First of all, we notice 66 is larger than 62.5, which is tenth of the 25 squared. So the entire expression now is larger than 576 times 25 squared plus 62.5, which is equal to 576 times 25 squared times 1.1. And 576 times 1.1 equals 633.6 times, and this number is larger than 25 squared, and the entire expression is larger than 25 to the fourth power. And from here, we are able to prove that 6/5 to the square root of 3 larger than 5/4 to the power of square root of 2. Thank you.